Okay, we're still in section 2.2 here, talking about quantitative data and common illustrations that you can make. A common illustration that you can make is a stem and leaf plot, and a stem and leaf plot is a way to represent quantitative data using the actual digits given in our data. In a stem and leaf plot, we use the digits to the left of the rightmost digit to form the stem, and then the rightmost digit forms the leaf. Okay? For example, if the data value were 147, then we would have 14 as the stem and 7 as the leaf. Okay? To draw the graph, we write the stems in a vertical column in increasing order, and then draw a vertical line to the right of the stems. Next, write each leaf corresponding to the stems to the right of the vertical line, and the leaves must be written in ascending order, that is smallest to largest. There's a note there. If no data values are in a class, you should still write the stem number, and the leaf row is just blank. Okay, and we'll see that. Do not put a 0 in the leaf row if there are no data values to list, okay? Because that can be mistaken for a data value then. Okay, so the main thing with the note there is to not skip stems. Okay. Problem 16 is where they want us to construct a stem and leaf plot to represent the data from question 5. Okay, so question 5 was the Yellowstone, or the Old Faithful Geyser in Yellowstone National Park data, and there's 44 different eruption times listed here. Okay, and so we're going to construct a stem and leaf plot to represent this data. Okay, the first thing I have to do is I need to make my stems, and the stems are these numbers here. So I ignore the rightmost digit. Okay, so if I look at a number in the 90s and I ignore the right digit, that's going to leave me with a 9, right? So my first stem would be 9. And then if I look at numbers that are in the 100 to 109 group and I ignore the right digit, that leaves me with a 10. If I look at numbers that are in the 110 to 119 group and I ignore the right digit, that leaves me with the number 11. And then now the biggest data value that we had was 120. Okay, so if I ignore the 0 in 120, then I get a 12. Okay, so my stems would be the numbers 9, 10, 11, and 12. Okay, and now the next thing I have to do is I need to arrange all the leaves. Okay, those are all the rightmost digits that I was ignoring. So I had 2 90s, so I'd write 2 zeros. Okay, I didn't have any 91s, and remember I need to go smallest to largest here with the leaves. So I did not have any 91s. There was a 92. Okay, so I write a 2. I did not have any 93s, but there was a 94 right here, and so I write a 4. There was a 95, so I write a 5. I did not have any 96s, 97s, 98s, and there was, looks like 2 99s. Okay, so I put 2 9s there. Okay, the first row in my stem and leaf plot is done. Okay, and then do the second thing for the numbers that are in the 100 to 109 group. Okay, so let's see here. I have 2 100s. There should be. There's 1, and there's 2. Okay, so you have 2 zeros. There should be 4 101s. Okay, so there's 1, there's 2, there's 3, and there's 4. Okay, so I'm going to write 4 1s. There are 3 102s. Okay, there's 1, there's 2, and there's 3. All right, 3 2s. There are 5 103s. Yeah, there's 1, there's 2, there's 3, there's 4, and there's 5. Okay, so I ignore the 1, 0, and I wrote 5 3s. Okay, and then there's 3 104s, there are 3 105s, there are 2 106s, there's a 107, there are 3 108s and 2 109s if you look at the data set. Okay, so I've arranged row 2 here. Now row 3 would be when I look at all the digits that are in the 110 to 119 group. So it looks like there are 5 110s. So let's check that there. There's 1, there's 2, there's 3, there's 4, and there's 5. Okay, so I'm going to have 5 zeros. There's a 111 right here. And so I write a 1. There are no 112s. There's a 113 and a 116. So there's 113. Okay, and then 116. Let's see here. 116 is right there. Okay. And that's it for the 110 to 119 group. The biggest number that we had was a 120, and so I'd write a 0 there. Okay? And my stem and leaf plot is done. Okay? Now, you can determine the shape of the distribution just like we did with a histogram. Okay? And this happens by tilting our head to the right. And so if I tilt my head to the right, it looks like I have something that is pretty bell-shaped, right? In fact, this reminds me of the histogram that we created back when we had a width of 10. Okay? It's the same thing. There's 7 numbers, 28 numbers, 8 numbers, and 1 number. Okay, and I should have 7 numbers, 28 numbers, 8 numbers, and 1 number. Okay. Now, what if I had an eruption time that lasted 152 seconds? Okay, and so I had a 45th eruption time, and 152 would be the number. Okay. So what I would do with my stem and leaf plot is I would continue this vertical line here, and to the left of that, I would write the numbers 13, 14, and 15. Now, I did not have any numbers that were in the 130s or 140s, but I still want to write those stems. Okay, so what's important here is that you don't ever skip stems. Okay, the biggest number that we had was a 152. So I would just write a 2 by the 15. Okay, if that were to happen, you know. Now, problem 17, state an advantage and a disadvantage for stem and leaf plots versus histograms. Okay, so what is an advantage over a stem and leaf plot that we just made versus a histogram, which is here'd be a similar histogram. Okay, well, an advantage for stem and leaf plots versus histograms is that the raw data is not lost in a stem and leaf plot. So here, you know, when I create the stem and leaf plot, like I can see all the numbers. Okay, I got, there's 2 90s, there's a 92, there's a 94, there's a 95, there's 2 99s, etc. Okay. In a histogram, I don't know what those numbers are. Okay, I only know that there's 7 numbers in the first group, that is the 90 to 99 group. I have no idea what numbers those are, though. Okay, so that's an unfortunate thing with a histogram, is that you lose all the data. Okay, a disadvantage of a stem and leaf plot versus a histogram, I said that stem and leaf plots are not well suited for large data sets, and there's more flexibility in choice for classes with a histogram. So with a stem and leaf plot, you only can have it where the rightmost digit is the leaf, and all the numbers to the left are stems. That is the only way that you can have it. Okay, So this is the only possible way to make a stem leaf plot for the data set that was the eruption times. Okay. Whereas in a histogram, so I could make my histogram, just like that, or we saw that you could change the width, and you can make a so here's 90, 95, 90, 100, right? So using a width of 5. So there's way more flexibility with a histogram than a stem leaf plot because I have the freedom to choose the width that I want. Okay, problem 18 says the data below represent the combined state and average local tax rates, which are in percent, in the year 2017 for all 50 states plus the District of Columbia. Okay, so I got 51 numbers total. There's a note there saying that sometimes the data must be modified before a stem leaf plot can be made. For example, the percentages that are above are reported to the hundredth decimal place. So if we use the integer portion of the data as the stem and the decimals as the leaves, then the stems would be 0, 1, 2, 3, 4, 9, but then the leaves would be 2 digits, okay, such as 25, 76, and so on. This is not acceptable for a stem leaf plot. Okay, since the stem and leaf plot, you can only have single numbers as the leaves. Okay, it says each leaf must be a single digit. So to resolve this problem, you can round these numbers here to the nearest 10th position. And so that's what I've done. So 8.25 rounds to 8.3, 1.76 rounds to 1.8, 9.01 rounds to 9.0, 9.30 rounds to 9.3, okay, etc. So I rounded each of the data values that are listed here to the nearest 10th of a position. In part B, I wanted us to construct a stem leaf plot for the modified data, that's the numbers that were rounded to the nearest 10th, and then we'll comment on the shape of the distribution. Okay, so let's see here. So 0, there should be 4 zeros. So here's 1, here's 2, here's 3, and here's 4. Okay, and by the way, I'm going to go 0 to 10. Okay, since all these numbers that were listed are percentages that go from 0% to 10%. And then 1, okay, so 1, let's see, it was 1.8, okay, right. I did not have any numbers in the 2s or 3s that were listed here. So again, I don't want to skip stems, right? I just write those stems and there's no leaves by them. There should be a 4.4 right here, okay. So I write a 4, write a 5, okay, and so I got my stems listed, and so 5.4, let's see, here's 1, 2, 5.4, yeah, just the 2 there, okay, and 5.5 is right here, 5.6 is right here, and then 5.8 is right here. Okay, and so that would be how I'm getting this row here. Do the same for 6, 7, 8, 9, and 10. Okay. Now, so here'd be my completed stem and leaf plot for the data. And they want us to comment on the shape of the distribution. Is the distribution shape best described as uniform, bell-shaped, skewed to the left, or skewed to the right? Okay, so if we tilt our head to the right there, or look at the graph like this, it appears like the bump in the graph is more towards the right side than on the left side. So I would call this slightly skewed to the left, okay, because the left tail, it appears to be a little bit longer than the right tail. Okay, I could also see an argument for calling it bell-shaped. Okay, but skew to the left or slightly bell-shaped is be the only two classifications that I would agree with. All right. Why don't we go ahead and stop the video right there?